I'm gonna make this one very quick, but let's just ask, how random are musical sequences? Well, what kind of question is that, you ask? You know, what is a musical sequence? Well, let's just say n equals interval, and a random musical sequence is just going to look like this. Just a bunch of intervals and a string. And so you're saying, well, all of these, every possible musical sequence could be random. Well, let me tell you, there are at least two formulas. There's more that we can use to find non-random sequences. Shoot, forgive me. And these non-random sequences are going to be linear and quadratic. And when we get to that more section, you say cubic. Anyway, a linear equation in music is just going to be one interval throughout. And our intervals are going to be 0 through 11. And it's going to measure semitones. So let's make a linear sequence with just semitones. So let's say R is root, R is flat second, plus flat second, plus flat second. I mean, if you know much about music theory, you'll probably start to recognize this sequence as the chromatic scale, because the chromatic scale is, I'm just gonna do that down here. Our chromatic scale is essentially just 12 notes in a row, all semitones. If I did this with fourths or fifths, this would look like the circle of fourths or circle of fifths, just 12 of one interval in a row. There are other intervals you can do this with, but you're not going to get as many as when you do it with flat seconds, fourths, fifths, and major sevenths. And R/O just represents root octave. Now this sequence is pretty easy to put together, considering you can see all the movements here, but let's show a quadratic formula real quick for a quadratic sequence in music. So again, let's just start how we did the first time, but now this is going to be our first difference, and let's say our second difference is right here, and our second difference is not going to be more consistent. So if we add a flat second to a flat second, that's going to give us just a second. And so a second away from the flat second is going to be the flat third. And now this is going to be a flat 2. So this is going to be a flat third. Flat third away from a flat third is going to be flat fifth. Yes. Anyway, you're going to start to see this sequence develop in a familiar way again. A third plus flat is going to be flat seventh. I'm just gonna cut this off kind of short. You'll get the point no matter what. Basically, if we look at our linear sequence, we only have a first difference, and the first difference is linear. And now our second difference is linear now, right? So theoretically, I mean, we could keep going down and down and down and down until we get linear differences, linear third differences, linear fourth differences. It could go on for quite some time. And there's even more things you could do. Once you've figured out the general sequence equation, you could do alternating signs. So let's say now we have a plus a semitone and then minus a semitone. Right, this is going to be, all we have to do to make an alternating formula is just have alternating signs, positive and negative. And then if this were to be quadratic, it's going to even look a little funkier. Right, so you're going to start getting slightly more different and unexpected results. Probably one of the weirder things you can do is the Fibonacci sequence, which is going to look like this. And let's just measure this in half steps. So let's say we'll just use one half step for this and one half step for this. Really, as long as you don't pick 0 for either of these numbers, they could be the same or different, positive or negative. Fibonacci sequence is more like Fibonacci and then apostrophe S sequence, because it's like where he took it, but you could make it more generalized if you want. So say 1, 1 plus 0, 1 equals, and then 1, 0 plus, 0, 1 plus 1, 1, forgive me, 1, 1 plus 1, 1, and then you see these two ones are going to add, and this 1 and 0 are going to add, so 1, 1 plus 2, 1. This is going to just keep going on forever, as long as you make sure that all these numbers are the sum of the previous two numbers. Alright, so it's going to be 1, 1, 2, 3, 5. 1 plus 1 equals 2, 2 plus 3 equals 5. The next number will be 8. And again, if this is a musical sequence, let's just say, let's measure this in half steps. So 1 half step would be a flat second, plus flat second, plus a 2. So it's going to be 3, plus a flat third. This is 3 half steps, and this is 5 half steps. It's going to be a perfect fourth. Flat third of a 3 is going to be 5. and then plus 4 is going to be that. So that's going to give you the first root plus 1, 2, 3, 4, 5. So this is just going to be a 6-note sequence of the Fibonacci if you use 1 for both the numerals. Anyway, 10 minutes is a bit too long now, but use this to ask yourself how random are musical sequences, if random at all.